Hey guys, my name's Lau. We are going to review Sovol SVO6 today. It was released in October 2022 with MSRP at $299. This printer is targeting an entry-level budget 3D printer market. Let's see what Sovol offers us with its price. Now this printer is very similar to Prusa mk3s, or you can call a clone. But when you look at some of the detail, you will see there is a lot of small difference in design. It is definitely not a copy and paste product. Same as the mk3s, SVO6 also comes with linear rought motion system. It is rare to see on a budget 3D printer. I think it may be the only one in the market right now that is under $300. Let me know in the comment section below if I am wrong. Linear rought motion system could run much faster compared to traditional T-slot with wheels, but it also requires more maintenance as well. A pulley loop, linear rod, and bearings could produce a lot of high-pitched noise and vibrations. This machine comes with direct dry extruder with inductive sensor for auto bed leveling. The extruder also has a unique design. The printer gear set is offering a small gear ratio to feeding the filament to the full metal hot end. Sovol states that this hot end could reach up to 300 degrees, which is able to print some high temperature filament like polycarbonate and carbon fiber. This printer also comes with dual Z-axis, a single-side PEI sheet, 32-bit mainboard with silent step driver, belt tensioner, and sensorless homing. The actual print volume for this printer is 220mm x 220mm x 250mm. That's how it looks like compared with a standard size human after it's fully assembled. For those who want to know how much electricity it consumes, it is rated at 9 watts when it's idle, with around 300 watts initial heating for print PLA, 205 on the nozzle, 60 on the bed. It will drop down to around 90 watt to 100 watt. Continue printing, remain the same until it's done. Why do you want to know that? My ex-wife was asking me how much electricity it would cost before I bought my first printer. And now, I have many printers at home, but have no wife. With that being said, let's get started. We have one menu and two instruction paper, one LCD screen, one filament holder, a box loaded with tool, bolt, and accessories, one pre-assembled gantry, direct dry extruder, power supply unit, and the base of a printer. Now I'm gonna put everything on the table just to show you what's come with the printer. There is pre-cut slot on the base. Place a gantry on the slot. Use a step 1 bolt to secure the gantry. Place the power supply on the right side behind the gantry. 2 step 2 bolt is used to lock in tight. Step 3. Place the extruder on the carrier, put 3 M3 bolt, and lock it tight. Step 4. Put the filament holder on top of a printer and use step 4 bolt to lock it tight. Let's connect the LCD screen cable, Z-axis cable, power supply cable, Z-axis cable on the left, plug in X-axis motor cable. Cut the zip tie on the ribbon cable and bring the ribbon cable around the gantry, attached to the brew holder. Press down and lock it tight. Now always remember to switch the power supply unit voltage according to where you're at. As I am in the US, I need to switch to 115 volt. We need to adjust the belt tensioner. Use your finger to feel the belt. It should be slightly loose and give you enough rebound when you press down. It cannot be too tight and too loose. Make sure the cable on the back won't cut on the black plastic as you move the bed forward and backward. Move the extruder to the middle. I just realized my y-axis linear rod is a bit dirty and barely has any root on it. First, select bed leveling, auto Z align. Extruder will move all the way to the top. Remember to move the extruder in the center before you do that. The grinding sound is normal. Next, select bed leveling, auto home. It requires to heat out the bed. Due to the thermal expansion, the bed will expand as it heats up. Now we can select bed leveling, probe Z offset. It allows you to set the compensate for Z axis. Take a A4 paper and place under the nozzle. Slowly adjust the knob counterclockwise to set negative Z offset and move the nozzle closer to the bed. You'll feel some friction as it gets closer to the bed. It is normally around negative 1.6 to negative 2.0. In my case, it is negative 1.89. It is important to scroll down all the way and start the setting. Now we could select level bed to start auto bed leveling. Machine will heat up the nozzle and bed, and then it will do its job to automatic leveling the bed. Yeah, automatic. The whole process should take around 3 minutes. Finally, we can start printing some parts out. I'm excited! As I'm going to print PLA, so I just select the preheat PLA. Or you can select any temperature you want from the temperature menu. It is a lot easier if you straight up the bottom end of the filament and insert the extruder. It'll be a lot easier. We can rotate brew knob clockwise to fit in a filament. Sovol provides slicer and cooler file on the SD card comes with the machine, but I personally use Prusa slicer more often. At this point, there is no printer preset on this printer at Prusa slicer. I'll just go ahead to create a new setup by using the Prusa mk3s profile and just change the bed size. Alright, let's try a calibration cube first. I have no issue to print with the initial Z-axis setup. I like to use a white PLA to test a print. Since PLA is a lot easier to print and the white color was shows the layer defect a lot obviously. This print came out okay, but there is a nice line above the X and Y and below the X and Y, as you can see. As I'm not so satisfied with the first calibration cube, so I just go ahead to make some cell change on the slicer and also printing with different speed to see what's the limit of this printer. The layer shift issue didn't fix, and the print quality in fact are similar to each other. Besides, the slower speed has slightly better print quality than the higher speed one. And as the speed goes up, there is some under extrusion happens on top of the Z. Now I try similar setting with the first print in this blue filament. And result come out okay, as the blue filament hides a lot layer imperfection, but the problem is still there. I print out 3 benches with different speed setting. The layer looks good, and the detail finishing looks good too. There is no cooling overhang issue as well. As you can see, when with the speed goes up, the print quality start dropping a little bit, but I think 70mm is a sweet spot. Now I would like to try out this flex lag octopus to test out our accuracy. All the legs are able to move in freely, even the 2 smallest one on the bottom. I like to go ahead to try out some PETG. This PETG is already left in my room without any enclosure or sealed, almost a month. The both print came out very nice. There is not a lot of stringing, and the overhang looks okay too, and nice glossy finish. But I noticed that as PETG sticks so well on the print bed, the white line on the PEI sheet, it seems to stick on the print, just come off. I like to go ahead to try some pressure test for this machine. I print out this 18 hour and 25 minutes beam with 100mm speed. Now, when the first layer going on, I noticed that on the bottom left corner, it is higher than the other 3 corners. But it doesn't seem like it's gonna do anything to the print, so I'll just leave it for now. This print was done over the night. At the second day, when I wake up, I saw all 4 corners are all whopping. But the print's still going on, so I just let it go. Now, because of the high print speed and the bad whopping on the 4 corner, the layer finishing are not good. But since it's a trash can, it will do its job. I'll just take it. There is also a lot of stringing on the surface of the print. Now I'm having issue with printing TPU on this printer. The flexible filament is always jamming inside the gear set and cause a print fail. By reduce the retraction to the 0, it seems like it's printing, but the stringing are horrible. And later on I figured out it's because of the starting G code that caused the issue. After everything set correctly on the slicer, this vice rose came out really nice. As Sovol stated, this hot end were able to reach 300 degrees. I would like to test on high temperature filament. ABS were first test. However, in the beginning of a few prints, the ABS doesn't seem like to stay on the PEI sheet that well. I also tried the glue, but it doesn't help at all. Until I increased my Z offset from -1.8 to -2.0, and it just started working. Polycarbonate is also tested, and I feel one very challenging print on it, as you can see on the video. The first print failed due to the movement of the bed, and I add the support on the bottom. This ABS looks really nice. And I also print out another polycarbonate. It looks nice as well. Over. Pancho, stop meowing. No, you don't go in. Say hello to reviewers. This bad boy is meowing all the time. Okay, I'm just gonna hold him and talk about my final thought. Overall, I like this printer. It is easy to build. You should be able to build within 10 to 15 minutes even if you are totally newbie. Come on, stay quiet, don't move. The blue color part is made by injection molding, which looks very nice. Sovol also mentioned on the Facebook group that they're gonna share those blue parts on STL file soon, which is awesome. This machine could print many different filaments with a decent print quality. Linear rought set are able to reach 1000 mm/s as accelerations, and it makes prints a lot faster than any other T-slot 3D printers. But it runs loud if it is pulley root, which my machine came with pulley root and it's very loud, as you can see as I mentioned in the early video. I don't like it still using micro SD card and the slot is located behind the printer. It makes it hard to take in and out if you put your printer in the tight spot. Now the printer gear set is working properly most of the time, but it is not very friendly to work with flexible filament like TPU. And I'm not the only one who has this issue. I fixed my problem by changing starting G code, and since then, I have running 5 prints with absolutely no issues. So I'll call it fixed. The part cooling fan is located at the bottom of the extruder head, which make it very hard to see the first layer. Now, as early production stage of this machine, there are still some minor issues with design and the production quality control, like the LCD screen carrier, the filament feeding hole in the extruder, printer bed spacer. But with my previous experience, Sovol is doing some sort of continuous improvement with their product, which I hope they will fix those issues in the later on. Like any other entry-level printer out there, there will be some minor issues. Now, some people are going to argue that they paid money, so they should get one faultless machine from the manufacturer. But that's not the case with 3D printers, at least entry-level 3D printers. It requires some sort of troubleshooting, and there's also a learning curve on that. Now, manufacturers make all the features that you want on a 3D printer, and they fix every single minor issue for you. Then it will cost $3,000 and more, not $300. Now, you don't want to make a 3D printing hobby become a big financial decision and put a hole on your wallet. That's why printers like Ender 3 and Sovol SVO6 become more desirable. As a beginner, you could spend $300 and see if you like it or not. Even if you don't like it, you're not going to lose a lot of money, and it will not hurt you long term. Which I'm going to emphasize money versus value more in a future video as well. Sovol SVO6 may not be absolute best one for the beginners, since it requires some tweaks, but it is offered a lot for its price. Let's leave it at that. It is one of the best entry-level 3D printer currently available. Thank you for watching, and I'll see you soon. What? I'm checking out my first layer.